Okay, in this problem, we have somehow a lengthy problem. I hope we can solve this within a shorter time. Now, in the figure shown, if the atmospheric pressure is 101.03 kilopascal and the absolute pressure at the bottom of the tank is 213.3 kilopascal, so at the bottom, 213.3. What is the specific gravity of the olive oil? Sama ng olive oil there. See, this is the olive oil. We're looking for its specific gravity. Here, so we have here mercury. Weird. I don't know why they put this problem, but na mercury, then ay olive oil, na water, then ay SAE oil. Sa ginang meaning ng SAE, aturan ng i-quiz on niya. Kung sa meaning na niya. But it's an oil with, of course, specific gravity of 0.89. As you can see, ang olive oil naman sa middle. So perhaps olive oil will have a specific gravity higher than what? Than water. Kuna sa bus, no? Mercury is the heaviest, 13.6. Ang specific gravity meaning 13.6 times higher than that of water. Water, of course, will have a specific gravity of 1. Oil is 0.89. But olive, I see. Oh yeah, olive oil man. I don't know, but let's just try to check. So here, if S is known to be, wait. So if S is known to be 0.89, actually we know then what will be its raw, right? So raw oil, for example, raw of this will be 890, right? Yes, that's true because you just multiply that. Here, raw of water is 1,000. Here, raw of olive oil, that's what we don't know at the moment. Or you could just put here raw olive oil. Olive oil. Here, mercury, of course, we know if it's 13.6, the raw will be 13,600. Okay? So, simple as that. Now, ang simple lang yung gaya siya. This is the free surface, then we simply write how we do things. Okay, we start from here. At the top, we are given. What is the pressure at the top? Well, it's given to be atmospheric, and here it's given the pressure at the top is known to be what we call top. No, pasensyahan na ang aging ang dili maklaro. That's 231.3 kilopascal, and this is absolute. Okay? Absolute na siya. Marag tubig, absolute. Dili Wilkins. Anyway, now sa bottom, it's what? It's known. At the bottom, pinakaubos sa mercury, we're given also that the pressure is equal to P bottom is equal to 231 point, oh no, hindi 200, sayop ko. 231.3 ang babaw, ay ang bottom absolute. Pero ang taas, kani siya dapat. Kani siya dapat, 101. Okay. So dapat kaning top is 101.03 kilopascal. Okay? Ingana lang. Now, how do we solve this? Straightforward lang yun siya. Of course, dapat dili ta mag-solve dito sa S. We don't do that. We solve first for raw. Because we know when we know raw, we could simply get S. Raw of OO, olive oil. Okay, murag sa Popeyes, nasi olive. Now, let's try to see. Pero kanay pa lang danang murag nakita nato nga, well, it's weird. Will olive oil sink on water and not float? Well, let's try to check. Basin pagagamaan nga problem. Tinuod gyud ay. Okay, let's try. Well, as you go from the top to the bottom, what happens to the pressure? It simply increases by a value of raw GH. Of course, here, dili po diretso-diretsoon nimo kay you know that it's made up of layers of liquid that don't mix. So, therefore, we can have here, Kandana, as you go down, it increases by rho GH. And therefore, P at the top, so we write that P pressure at the top, plus, you go down by that the pressure increases by rho. What's that rho equal to? Well, okay, wait. Ato na lang isulat bityo para dali. So it will be at pressure at the top 101,030. Okay? Dapat dili man kilopascal, but pascal dapat. So at the top, that's the pressure. So go deeper, it increases by rho gh. But what is that fluid in here? It's the oil. Rho is 890. So you write here 890 times what? G. G is 9.81. What is H? H is known to be, well, it's given 1.5. So, and you go further, deeper, well, same thing, you add. But here the fluid is water, so the density will be 1000 times 9.81 times, oh, of course, it's 2.5. Ang yahang depth. Again, go deeper. Well, we don't know what is raw of olive oil, so that we make that our unknown first. Raw olive oil times what? 9.81 times, of course, we know the depth, 2.9. So because of that, palain. Ano pa? Paano nakaabot sa bottom? Well, oh, napag-isa sa pakakuan, move. So it increases further by rho 13,600, G is 9.81, and depth is, well, 0.4. 0.4. Okay, that's 0.4. So we say 0.4 na siya. Then, that is now equal to, pila may pressure diri sa bottom? Well, kung wala mong gid siya naigo ang point, no? But we know that as long as they are horizontally located, all the points here will have the same pressure, right? Yes, and that's P bottom equal to 231,300 Pascal. And therefore, from here, one equation, one unknown, you can solve for rho OO. OO stands for olive oil, of course. Then let us see. Wow, and we get an answer of 1,380 kilogram per m cube. And what do you mean by that? Well, mo na yung kuan, and what, therefore SG is a specific gravity of olive oil will then be equal to simply 13,000, 1,380 divide 1,000. Density of olive oil over density of water, that's 1.38. That's cool. Now I know that olive oil won't float in water but will sink. I hope that this is realistic. I will try to figure it out, no, for a quiz. I think that's it. That's how we solve things. Simple lang. Nahina lang itag-add. As you go deeper, you increase the pressure by rho gh. As long as rho is constant. And in this case, unlike the mud issue before, the problem that we have discussed, here the rho of water and the rho of olive oil, rho of mercury is not supposed to change, even if the pressure changes, because they are considered incompressible. But mud is not, mud is mixture naman na sila. And therefore, kato siya kay makompress pa. Okay, that's it.